So in this problem, I have to solve the rational inequality. X plus 2 divided by x minus 4 is greater than or equal to 1. Step number 1 of any rational inequality. First, get everything onto one side. So, subtract 1 from both sides. And I get x plus 2 divided by x minus 4 minus 1 is greater than or equal to 0. You will not be able to solve these correctly if you do not do that. Always get 0 on one side of the inequality, everything else on the other side. Then go about simplifying the inequality. So I have a common denominator. I have a denominator here of x minus 4, and I have 1. So I'm going to multiply my 1. I'm going to multiply my 1 by x minus 4 divided by x minus 4. So I end up getting x plus 2 over x minus 4 minus x minus 4 over x minus 4 greater than or equal to 0. I did that because I need the common denominator. So I have x plus 2 minus, and I'm going to use parentheses here, x minus 4 divided by my common denominator, x minus 4, greater than or equal to 0. X plus 2 minus x plus 4 divided by x minus 4 greater than or equal to 0. And let's simplify. Well, these x's here are going to cancel out. Positive x and a negative x. That gives me 6 divided by x minus 4 is greater than or equal to 0. Now, this expression, this inequality right here, is the exact same thing as our original inequality. All we did was move the 1 to the other side and then simplify. They are the same thing, just written differently. Now I need to go about solving this. I'm going to pause for a second. I'm going to try and make something clear. When I have a graph, and let's say the graph looks like that, and then let's say I had a vertical asymptote right there at 1, and then this kind of was going up, and it crossed 0, and then maybe a 2, and it's going down like that. Another vertical asymptote right over here at 3, and then this section right here is another branch, and it looks like that. I'm totally making this up, but the point I want to make is this. I'm doing an inequality. This graph is my graph of f of x. And let's just say I want to find out where is it less than or equal to 0. This is my graph of f of x. I'm looking for all of the points that fall below the x-axis, because those are the points, anything down here is where f of x is going to be less than 0. Anything above the x-axis, f of x is going to be greater than 0. And there's only 2 places that I can go from greater than to less than, or less than to greater than. And those 2 points are at a vertical asymptote or at a 0. Those are the only spots that the graph can make those changes. So this graph now has been divided up. I can divide this graph into different intervals based on the location, the x value of the vertical asymptote and the zeros. So I have one interval that's going to go here from negative infinity all the way to -1. Because everything from -1 this way here, in this graphic, is going to be positive. It can't change from positive to negative unless it crosses the x-axis or hits a vertical asymptote. And between -1 and -infinity, I'm not crossing the x-axis anywhere, and I'm not getting any other vertical asymptotes. So all of the values from -1 to -infinity are going to be positive values. Well, I have another interval here. It's between this vertical asymptote and 0. So this interval here, I'll put a little arrow, is the interval -1 to 0. And all the values in that place are going to be negative, because that's what my graph is. My graph is negative. Then I have another interval from this 0 right here to the +2, 0. This interval right there, that is from 0 to 2, and all of those values are positive. Then from 2, I can't change anywhere between 0 and 2, because there's no zeros and there's no vertical asymptotes. But as I'm going from 2 over towards 3, there's a vertical asymptote at 3, so I have another interval that is the interval 2 to 3. And then I hit another vertical asymptote, and I can change from negative to positive at a vertical asymptote, and my final interval is from 3 to infinity. So I'm looking for zeros and vertical asymptotes, and I'm breaking up my graph into intervals based on that. Here's one interval, here's another interval, here's another interval, here's another interval, and then here's the final interval. So I have 1, 2, 3, 4, 5 intervals in this particular graph. In this particular graph, if I want to find where is f of x less than or equal to 0, well, it looks to me like the only places that it's less than or equal to 0 is this piece right here and this piece right here. So those two intervals where it is less than or equal to 0 are the intervals, what did I say here? -1 to 0, -1 to 0, and 2 to 3. But since I asked where it was less than or equal to 0, it is equal to 0 at 0, and it is equal to 0 at 2. So this 0 becomes a bracket, and this 2 becomes a bracket. And that would be the answer to this problem. So what do I do with that? Why am I going through all that rigmarole when that's not even my problem? Because I have a rational function here. And this rational function has a vertical asymptote at x equals 4. Because that's what would make our denominator equal to 0. My numerator is 6. I have no x-intercepts in this graph. It's just 6. There are no values of x that are going to make y equal to 0. So I don't have any zeros. So the only place that my graph can change from positive to negative or negative to positive is at x equals 4. So I'm going to make my number line here. 0, 1, 2, 3, 4, 5, -1, -2, 3, 4, 5. And I know the only place it can possibly change is right there. So all I have to do is test one number on that side and one number on that side. Because all the numbers, whether they turn out negative or positive, are going to be the same on this side and the same on that side. So I think I'm going to start testing out, I'm going to test out the number 0. So I have 6 divided by 0 minus 4. That would be equal to 6 divided by -4. And even though I can see very quickly that it's the same as -3/2, I could tell right here that this was going to be a negative number. So everything to the left of 4 is going to be a negative number. Now let's test to the right of 4. Let's test the number 5. So I would have 6 divided by 5 minus 4. That's 6 divided by 1. Everything there is going to be positive. What is my inequality asking for? It's saying, where is it greater than or equal to 0? Well, it's going to be in this interval here, the interval from 4 to infinity. And 4 is not included because 4 is not equal to 0. 4 is an asymptote, and asymptotes are never included. So that's why it has the parentheses. So that's how you solve one of these problems. It has a lot of stuff to it. It starts out with step number 1, which is super important, getting everything to one side. It uses common denominators so that you can simplify your rational expression as much as you can. It deals with vertical asymptotes, so that you know where it can switch. It deals with zeros, which there aren't any here. But the last thing I'm going to do, is I'm going to check my work using a graph. So here I've set up the equation into my calculator. 6 divided by x minus 4. I want to do it in the form where I have it greater than or equal to 0. And I'm going to graph it. And sure enough, I think I'm correct. It looks like I have a vertical asymptote right there at positive 4. Everything to the left of the vertical asymptote is negative. Everything to the right of the vertical asymptote is positive. I confirm that my answer is correct.